All right, let's look at the pulley on an incline problem. And the first thing we want to do is identify all external forces acting on each body. That's the first thing we want to do. So let's put our center of mass here and draw our normal force perpendicular to the plane. That's Fn. We have the gravitational force that comes straight down. And for this second body, we have the gravitational force that comes straight down. So we can say this is Fg2, this is Fg1, and both of these bodies have different masses. So this is 3.7 kilograms. This second mass is 2.3 kilograms. So this is M2, this is M1. Okay, so now we need to draw the components of each force. The normal force is completely perpendicular to the plane of incline, therefore it will have no x component. However, we have a gravitational force which will have an x and y component. So, right angle. So now I've drawn in the x and y components of the gravitational force, and Fg is equal to M1G. It'll be this mass times G, and let me write out the components here very quickly. And I like to write out Fg parallel is equal to Fx, which is equal to a negative M1G sine of theta. Let's do the y component. I like to write out Fg perpendicular equals Fy equals negative mg cosine of theta. Now, for this component, let's take a very good look. I'm choosing number 2, identify the positive directions. And I've pretty much implicitly did those. So the positive direction, with this being the center of mass, the positive direction would be going here, up, forward. The positive direction with this being the center of mass would be this going up, forward. Anything after that center of mass that goes below, its direction would be negative. Now, I said that to say, since we have a rope or cable involved, I'm going to go ahead and draw in my force tensions. And I'm going to call that FT1, and that's going to be FT2. But what we do know, these are vectors, but what we do know is that FT1 equals FT2. They have the same magnitude. And when we solve our equations, I'll just refer to that as simply as FT. So keep this in mind for right now. Now, I would usually draw out a chart of the forces and how they're acting, but we've worked enough problems and we can see exactly what's going on. We have the force tension, and we have the parallel component of the gravitational force. So what we can do is, like I did in class, we can set up these two equations. So the first thing we say is Ft, simply the magnitude, minus mg sine theta equals mass. It equals mass times acceleration. But first we need to make a guess as to which way these bodies are accelerating. Is it going around this way, or is it going around that way? That we don't know. So let me just say that acceleration is going in that direction, and it is positive. So if I say it's going in that direction, positive, when it comes down, acceleration in that direction must be negative. Okay? So going that direction, positive, coming down, acceleration would be negative. So for my first equation, Ft1, and that should be a m1 for mass 1, is equal to m with a positive acceleration. My second equation, we're going to say Ft2 minus m2g equals m minus acceleration. Okay? So now remember I said I would, for equation solving, this is EQ1, this is EQ2, and I said for equation solving, I would just drop the subscript of 1 and 2 for FT because they are equal. Now, what I want to do is, since the tensions are equal in magnitude, I need to sum these two equations to eliminate tension. When you add these two equations, your tensions will always cancel out. But if you see here, I have a positive tension here and a positive tension there. So let me rewrite equation 1. And that's Ft minus M1G sine theta equals MA. Now equation 2, I'm just going to do this in my head. I'm going to multiply through by a -1. So that would be minus Ft plus M2G equals MA. And that should be M2A, and this is M1A. All right. So now what I can do is I can cancel my tensions, and I'm left with an expression that says, adding these two equations together, M1G sine theta Let me rewrite that. I'm left with an equation that says M M2G minus M1G sine theta equals M1A plus M2A. So at this point, we're trying to solve for acceleration. Now, I have a G in both of these terms, and I have an A in both of those terms. So let me factor out a G and have G times M2 minus M1 sine theta equals, let me factor out an A on this side, A times M1 plus M2. Now what I can do is I can divide both sides by M1 plus M2. Divide both sides by M1 plus M2. These cancel, and essentially, running out of space here, So essentially that is my acceleration. This is my acceleration. So when I plug in these numbers, I find my acceleration. So let's see what that is. That's going to be 9.8 times M2 is, let me write out the correct units, 9.8 meters per second squared times M2 is 2.3 kg minus M1 3.7 kg times the sine of 30 degrees. Now, all that is divided by M1 plus M2. So M1 plus M2 is 3.7 plus 2.3, and that gives you 6 kilograms. So now A is equal to, let's do this math. That would be 0.7 2 times 9.8 equals divided by 6 equals, and we have an acceleration of 0.735 meters per second squared. Okay, so we found a positive acceleration, and that meant our guess was correct. Our guess was correct. So it accelerates in that direction positive, and in this direction, the sign becomes negative for acceleration. And now, let me section off a piece. We need to find the force tension. We need to find the force tension. So if you look at the problem is somewhat worded in a manner that you cannot completely understand. Part B, the direction of acceleration. So the direction of acceleration would be in this manner here. This would be your direction of acceleration. Okay, so if you didn't understand what part B was asking, that means that block 1 is coming up the incline and block 2 is going down vertically. That's exactly what part B is asking for. So we did find the correct direction of acceleration. Now, let's find the tension, the force tension that is acting on these bodies. Well, we had to find the acceleration first. So we can choose any equation and plug in to solve for the force tension. So let's use equation 1 and say that Ft minus, I'm going to go ahead and put in my numbers, M1 is 3.7 kilograms times 9.8 meters per second squared times the sine of 30 degrees, and that is equal to the mass of number 1. Let me make that clear. That's equal to the mass of number 1. So the mass of 1 is 3.7 kg times our acceleration, going off my whiteboard, 0.735 meters per second squared. Okay. Now let's do away with some of this math. Let me see what this is equal to. We have 3.7 times 0.735. That's equal to 2.72 newtons. And let's see what all this stuff is equal to. We have Ft minus, let's see, the sine of 30 is 1/2. So that would be 9.8 divided by 2 times 3.7, and that is equal to 18.13 newtons. So let me bring this 2.72 closer. Now, to solve for Ft, we just simply take 18.13 to the other side, so that would be 2.72 newtons plus 18.7, 18.13 newtons, and that sums up to be what? That's 20.85 newtons. So, this is our force tension, our magnitude of our force tension. So this is part C. This is part when I explained about this block coming up the incline and this going down. This would be part B. And the magnitude of the acceleration, that would be part A. Now, the last bit of information is I've worked this one a little different than in class to give you more than one perspective on how to think about these problems. This is the stripped down version where you don't have to think too much about what's going on. So please view and if any questions, ask in class. All right, so our next class meeting, we will be starting chapter 6, dealing with the force component, dealing with the additional friction force, which is just one more force added to our free body diagram that we will have to calculate for. I would encourage you to work this problem, look at the handout, look at the differences in how I work the problem, and figure out which method you are most comfortable with, and ask questions in class. This may appear on a quiz or an exam in the very near future.